So today we're looking at solving equations by clearing the fractions. And so to do that, we can find the least common denominator. And if we're looking at our denominators, I have a denominator of 2, 5, 2, and then with the 7, remember that would be 7 over 1. So we have a denominator of 1 there. So if we're looking for the least common denominator, that is the least common multiple of 2, 1, 5, and 2. I wouldn't need to write it again. So you could list out the multiples of each of those denominators. So 2, 4, 6, 8, 10, 12. For 1, we don't really need to consider 1 because every number is a multiple of 1. For 5, 10, 15, 20. One of the strategies that you might want to use, you could start with your largest number. You could go through the multiples. If we start with 5, 2 is not a factor of 5. If we go to 10, it's a multiple of 5. It is a multiple of 2. It is also, if we kept going with this list of the multiples of 1, it would also be in that list. So the least common denominator is 10. So one strategy, we can multiply each side of the equation by 10, and then we would have to use the distributive property. So we'd have to multiply the 10 by 5x over 2. We would also have to multiply the 10 by that negative 7. So sometimes you will see where people go ahead and distribute, and they're just multiplying each term by 10 on the left side. Whatever we do to one side, we have to do to the other. So we would also have to multiply. We'd have to distribute the 10 on the right side. So 10 times 3x over 5. And 10 times negative 9/2. And then when we multiply, we could go ahead and simplify those. And when we do that, it should get rid of the fractions. So if I am multiplying this first term, I have 10 times 5x, that is 50x, divided by 2. That would give me 25x minus 70. 10 times 3x is 30x, divided by 5 is 6x, minus 45 when we multiplied that last term. You'll see where sometimes people divide first. So we could do 10 divided by 2, and that is 5, and then times that 5x also gives us 25x. So it doesn't really matter which way you think of that. And then as soon as we get here, you guys know how to solve these equations. We have some x's on both sides. I'm going to choose to get rid of the 6x. So I'm going to subtract 6x from both sides. We get 19x minus 70 equals negative 45. Remember, my goal is to get this 19x by itself. So on the left side of the scale, we also have that minus 70. We want to get rid of it. So I'm going to add 70 to create that 0 pair. And so we get 19x equals 25. And if we divide both sides by 19, we get 1x, or just x, equals 25 over 19. And we can leave that as an improper fraction. We could divide it to get a decimal approximation. So x is approximately 1.3. The second strategy is very similar, but this one is finding common denominators and rewriting those fractions. So we've already decided that the least common denominator is 10. So we could rewrite every term with the denominator of 10. So if we go back to our fraction knowledge, if I'm writing 5/2 x as tenths, remember we would have to multiply by the giant 1. So I would multiply by 5 over 5, and we would get 25x over 10. Likewise, if I were going to write 7, which is, remember, 7 over 1, as tenths, my giant 1 would be 10 over 10, and we would get 70. For the right side, 3x over 5. If I'm going to write that as tenths, my giant 1 is 2 over 2, and we would get 6x, 9/2. I'm going to write that as tenths. My giant one would be 5/5, and we get 45 tenths. And then if we think back to what we know about adding and subtracting fractions, I have common denominators. So on the left side, I could write 25x/10 minus 70x/10 as 25x minus 70 all over 10. Likewise, on the right side of that equation, common denominator is 10, so I can write that as a common denominator, and then we have 6x minus 45. And using what we know about fractions, if my denominators are both 10 and those fractions are equal, then the two numerators would have to also be equal. For example, if I told you that this numerator was 7, then the numerator on the right side would also have to be 7 to make those fractions equal. We could have that same thought process here. We have 25x minus 70 tenths. That has to be equal to 6x minus 45 tenths. So those two numerators would have to be equal. So we know that 25x minus 70 has to be equal to 6x minus 45. And if we compare that to the method that we just did, that leads us to the same equation that we had before. So two methods to end up on the same path. We would continue solving that equation as we did to get x equals 25/19. We could also take that same train of thought to decimals. So if I'm looking at these decimals, that 5.1, that 0.1, we know is 1/10. The 0.02 is 2/100ths. The 4.9, the 0.9 represents 9/10. 2.18, that 0.18 represents 18/100ths. So if I'm thinking about my denominators, we have a 10, a 100, a 10, a 100. So that least common denominator would be 100. If we needed to, we could list out the multiples of 10 and multiples of 100, and we would find that that least common multiple is 100. So we know the least common denominator is 100. Again, we can multiply each side of the equation by that least common denominator. Since we're talking about decimals and our decimals are base 10, it would have to be some power of 10. So we would have to distribute. Again, some people, you might see them just going ahead and distributing by showing that they're multiplying each term by that least common denominator. Then we multiply 100 times 5.1 would be 510x minus 100 times that 0.02 gives us 2. 4.9x times 100 is 490x. 100 times 2.18 is 218. We have x's on both sides. I'm going to choose to subtract the 490x to create a zero pair. So I get 20x minus 2 equals 218. Again, we're trying to isolate the variable, so I'm trying to get the 20x by itself. On the same side of the equation is that minus 2 that we need to get rid of, so we're going to add 2 to both sides. We get 20x equals 220. 20x is 20 times x. To undo multiplication, we're going to divide both sides by 20, so x is 11. That is what it looks like when we clear the decimals.